To conclude, so what we've done, we've studied learning to rank in this lecture, and learning to rank, it's very much needed everywhere where we've done ranking of documents, and we have many features. Well, and of course, where we have training data. If we don't have training data, we should go back to those unsupervised methods that we discussed in the previous set of videos. But what we want from learning to rank, we want it to scale to large collections and be fast enough. Otherwise, many of those approaches could work if they were, well, if we were not looking for fast approaches. Many of the approaches that we discussed and rejected could be used, but like pairwise model, for example, where the model is applied to pairs of documents. But for these reasons, it should be scalable and fast. We need to create specific models, and usually we go with Pointwise model that calculates a score for a particular query document pair. And of course, learning to rank should be able to work with a large number of features. Well, the more the better. Now, we discussed 3 types of approaches. Pointwise approach was really nice and simple and understandable, and it just predicted relevance per query document pair directly. But of course, it ignored the ordering because it didn't consider the relationship between different documents, which is very important for the ranking. So this relationship was considered in a pairwise approach, where the loss considered the pairs of documents and tried to minimize the number of inversions between documents. But as we saw in the examples, not all pairs of documents have the same impact. So the optimized number of inversions, regardless of the importance of the pair, may produce non-optimal rankings. This approach is still used very often in industry, but the best approach, the best set of approaches, listwise approach, it optimizes the IR metrics, those offline metrics that we studied before directly, even though they are not differentiable. But the downside, it's more of a heuristic approach, although there are also more formal approaches that we mentioned in the end. But okay, it's more heuristic, but it's directly optimized the metrics, and that's why it's the best approach out there. And it's still used a lot, especially the approach like lambda rank or lambda mark that I mentioned before. Now, this observation by Hari is very important in my opinion, especially for the theoreticians of learning to rank and information retrieval, like we are for teaching. So what Hari realized after working a lot on LTR is that the distinction between pairwise and listwise is good, but to a certain extent. So it may not be very helpful at some point. The problem is that, in a sense, well, all the approaches are interconnected. For example, in pairwise and listwise approach, we still use a pointwise model. But even if we go down to losses, in the listwise approach, the losses are still kind of pairwise. The losses are for the pairs of documents. We still swap pairs, but we give weights to different pairs in the listwise approach. So the model is pointwise, the loss is pairwise, and well, but we still optimize the whole ranking. So this distinction between these 3 approaches is kind of questionable. For example, the lambda rank approach with the metric called average relevant rank is just equivalent to RankNet. So basically, the listwise approach goes down to the pairwise approach with specific metrics. So basically, and yeah, there are different mistakes that sometimes different methods called differently in different literature. So what Hari suggests, and I actually agree with him, we can just talk about non-ranking losses, where we don't consider the relation between documents at all. Those are pointwise losses, like regression loss or classification loss, versus ranking losses, where we consider multiple documents, usually pairs. Even in listwise approaches, we consider pairs of documents. So those are pairwise and listwise approaches. And this is much clearer formulation. And I think this is important to keep in mind that, so today I recorded those previous 3 videos on pointwise approaches and pairwise approaches, listwise approaches. Those are terminology that we use. It doesn't mean that all methods work like this. It's just a useful terminology, but in reality, maybe it's better to use non-ranking losses versus ranking losses. So to conclude, we discussed why learning to rank is different from machine learning because it ranks. It doesn't just predict labels. We discussed those three approaches, though on the previous slide I mentioned that this terminology may be questioned. We discussed, of course, the pros and cons of each approach to move on, and we discussed the most important methods to date, like especially rank and lambda rank. Now, if you want to play with LTR, there are very many toolkits out there, so you can use them. For example, this is from Rolf Javerman from our group. And then the list of references is on the next 3 or 4 slides. And in the next, so with this, we finish the discussion of learning to rank as a pillar. And actually with this, we also finish the discussion of what we call the offline phase of information retrieval, everything that can be done without the users involved. And in the next set of videos, we will discuss what can be done when our system is running and is producing some user interactions and what can be done with those interactions.